That's not true of all college math courses.
Then you'll probably find the
those designed for science and engineering students are often very much in the same vein as the courses you had in high school.
I certainly did.
It's the courses that form the bulk of the mathematics major that are different.
Not because the mathematics gets harder.
But some of those courses are usually required for more advanced work in science and engineering.
I think you'll agree that college math is
so if you're a student in those disciplines, you may also find yourself faced with this different kind of mathematics.
At high school,
if you did well at math in school, you probably got good at recognising different kinds of problems. So you could apply different techniques you learned.
The flavour of a cookbook.
At university,
full of
you have to learn how to approach a new problem, one that doesn't quite fit any template you're familiar with.
The focus
comes
is on
down to learning how to think about a problem in a certain way.
Thinking outside the box.
The first key step
is
learn to stop looking for a formula to apply.
Those designed for science and
engineering
to follow are often very much in the same vein.
Approaching a new problem by looking for a template, a worked example in a textbook or presented on YouTube, and then just changing the numbers often won't work.
Some of those courses are usually required for more advanced work.
So all that work you did at high school won't go to waste.
So if you're a student in those disciplines,
but it isn't enough for many of your college math courses.
You may also find yourself faced with this different kind of mathematics.
If you can't solve a problem by looking for a template to follow, or a formula to plug some numbers into, or a procedure to apply, what do you do?
So you can apply different techniques you learn.
The answer is you think about the problem a certain way.
You have to learn how to approach a new
Not
problem.
the form of the problem.
One that doesn't quite fit any template.
That's probably what you were taught to do at school, and it served you well there.
Learning how to think about a problem.
Rather, you have to look at what the problem actually says.
The first key step.
That sounds as though it ought to be easy.
Stop looking for a
but
formula
most of us initially find it extremely hard and very frustrating.
Approaching a new problem by looking for a template.
You have to work at it.
A worked example in a textbook.
You're going to have to accept going a lot slower than you're used to.
Changing the numbers.
Most of the time, you won't feel as though you're making any progress.
So all that work you did at high school
your goal has to be understanding,
but it isn't enough for many of your college math courses.
You should definitely try all the exercises.
If you can't solve a problem,
they're there to aid your understanding.
Or a formula to plug some numbers into.
You should also work with others.
Or a procedure to apply.
Few of us can master this crucial shift in thinking on our own.
The answer is you think about the problem a certain way.
A lot of what we'll be doing is not so much focused on right and wrong, but on learning how to think about a problem.
Served you well there.
Yeah, sure. At the end of the day, solutions are right or wrong.
The problem actually says.
But usually there are many different right answers, or different ways to the right answer.
But most of us initially find it extremely hard and very frustrating.
When you're learning how to think mathematically, it's how and why you got something right or wrong that's important.
You're going to have to accept
the only way to find that out
than you're used to
find out how well you're doing.
Most of the time,
is for somebody else to look at your attempts and critique your work.
Your goal has to be understanding.
It's not possible to automate the grading process. Maybe one day artificial intelligence will have advanced far enough for a course like this to be automated. Though frankly, I doubt it.
You should also work with others.
But right
now, few of us can master this.
You need feedback from other people. For a regular class here at Stanford,
a lot of what we'll
the professor and the graduate student TAs grade students' work and provide feedback
about a problem. Yeah, sure.
With an open online course solutions are right and wrong, where there are many thousands of students,
there are many different right answers or different ways.
So we have to go about things a different way,
and many wrong ones.
I've designed the
learning how to think mathematically,
so that the benefit comes primarily from doing the work and discussing it with other students.
The only way
Getting it right is important in mathematics.
To find out how well you're doing,
but in a massively open online course, like this, there's no way to guarantee that.
It's not possible to automate the grading process.
Not being sure if we are right, artificial intelligence will have advanced far enough is very familiar to we mathematicians.
Though frankly, I doubt
even very famous mathematicians
right now
have had the experience of thinking they've solved a problem.
For a regular class here at Stanford,
writing up their solutions, sending it off for publication, only for an anonymous referee to find an error.
With an open online course like this,
there is such a thing as right and wrong.
That's not possible.
But deciding between them can be very difficult.
So we have to go about things a different way.
So even the professionals have to live with never being sure
so that the benefit comes primarily from doing the work and discussing it with other students.
Part of this introductory session is a reading assignment.
Mathematics.
It gives you a bit of the history that should explain why today's mathematics students need a course such as this.
There's no way to guarantee that.
In Lecture 1,
not being sure
there'll be a short quiz on the reading.
Have seen our work.
Let me say a few words about the quizzes.
To we mathematicians.
If you were in one of my regular physical classes, I'd talk with you to find out if you had understood the material sufficiently to progress.
And writing it up,
but with a massively open online course, a MOOC, that's not possible.
An anonymous referee
you have to monitor yourself. The quizzes are one way to help you do that.
There is such a thing as right and wrong.
I'll say a little bit more about the quizzes
between
later.
them can be very difficult. So even the
But
professionals
before you start lecture
have
1,
to live with never
please
being
read
sure
a file called
whether they're
Background
right or
Reading.
not.
It's just over 6 pages long.
Part of
It's a
this
PDF
introductory
file,
session
so you
is a
can
reading
download it and
assignment.
read it offline.
It gives you a bit of the history that should explain why today's mathematics students need a course such as this.
Well, now you know what an in-lecture quiz looks like.
in lecture 1,
The next thing
there'll
I
be a short
suggest you
quiz
do
on the reading.
is view the video,
Let me say a
finding
few
your
words
way
about the
around the
quizzes.
course website. It will
If you were
point you
in
to
one
some
of my
particularly
regular physical
important things to
classes,
check out
I'd talk with
before
you
you
to find
start
out
the
if you
course.
had understood the material sufficiently to progress. But with a massively open online course, a MOOC, that's not possible. You have to monitor yourself. The quizzes
I'm
are
going
one
to
way
start
help
off with
you
a
do
question.
that. What is mathematics? I'll say a little bit more about the quizzes
That
later.
might
seem strange, given you've probably spent several years being taught math. Lecture 1, please read
But
a
for
file
all the
called
time schools
Background
devote to the
Reading.
teaching of mathematics,
It's just over
very
6
little,
pages
if
long.
any, is spent trying
It's a
to
PDF
convey
file,
just what
so
the
you can
subject is
download it
about.
and read it offline.
Instead, the focus is on learning and
If you're
applying
not
various
familiar with the
procedures
basics of set theory,
to solve math problems.
or you feel you need to refresh
Well,
your knowledge,
that's a bit like
you should
explaining
also read
soccer
the
by
5-page
saying it's
summary
a
on what
series
you
of
would need to know
manoeuvres
for
you
this
execute
course.
to get the ball into the
It's
goal.
also a PDF file you can download.
Both
called
accurately
supplements.
describe various key features,
So please take a look
but
at
they
both
miss the
documents
what and the why of the big picture.
before lecture 1.
If all you want to do is learn new
The one
mathematical
other thing I want to
techniques
do in
to
this
apply in
introductory
different
session
circumstances,
is let you meet my 3 teaching
then you can
assistants.
probably get by without knowing what
You
math
can
is
do
really
that by
about.
playing the video.
But if
meet
that's the
team.
case, then this isn't the
In
course
that
for
video,
you.
we'll all 4 try to explain
One thing
our
you should
thinking in
realise
creating this
is that a
course,
lot of school mathematics
we wanted
dates
to
back to
achieve,
medieval times,
and how we decided
with
to do
pretty
it.
well all the rest coming
Remember,
from the 17th
MOOCs are
century
very
at the
new.
very latest.
This may be your first one.
Virtually nothing from the
Definitely
last
the first
300
one for many
years
of us.
has found its way
So
into
this
the
is very
classroom.
much an experiment. So
Yet the world we
please
live in has
do the
changed
background
dramatically
reading,
in the last 10 years,
check out the Meet
let
the Team
alone the last
video,
300.
and I'll see you back at lecture 1.
Most of the changes in mathematics over the centuries were just expansion.
Well, most of the questions
But
on
in the
assignment
19th
1
century,
were for you to
there
just
was a
think
major
about and
change
to
in the
discuss
nature
with
of
other
mathematics.
students. But let me say
First,
just 1 or 2 words
became much
about the
more
last
abstract.
one, question 8.
Second, the primary
Well, question
focus
8 is related to
shifted from
Euclid's proof that there are
calculation and
infinitely many
following
primes.
procedures
Another
to one of
crucial point in that
analysing
proof,
relationships.
we looked at this number where P1 through
The
Pn
change in emphasis
enumerates
wasn't
the first
arbitrary.
n primes.
It
We
came
multiply them
about through
together
the increasing
and we add 1.
complexity of
And
what
I
became
mentioned
the
during
world
the
we are
proof
familiar with.
that this number is not always prime.
Procedures and
And question
computation
8
did not go
asks,
away,
how would you
they're
prove
still
that it's not
important.
always prime?
But in
And
today's
the
world,
answer
they're
is
not
you
enough.
have to find a
You
number
need
n
understanding.
such that when you do multiply
In
the
our
first n
education
primes and add
system,
1,
the change in emphasis
it's not
in
prime.
mathematics usually comes
well, how would you go about
when you
doing that? Well,
transition
the most
from
obvious
high
way is to
school
just
to
start
university.
searching. So you would start by looking at the
In the
first 2 primes,
1980s,
say,
I was
multiply
one
them
of a number
together,
of mathematicians
add 1,
who advocated
you get
a new
7.
meme to
Well, that is
capture what
prime.
mathematics is today.
Try another one,
Science
2
of
times
patterns.
3 times 5.
According to
Add
that
1.
description,
That's
the
31.
mathematician identifies
also
and
prime.
analyses abstract patterns.
Let's try another one, 2
They can be
times 3
numerical patterns,
times
patterns of
5
shape,
times
patterns
7
of motion,
plus 1.
patterns of behaviour,
That's
voting patterns
211.
in a population,
That's also
patterns of
prime.
repeating chance events.
Well, at this point,
and
you're
so
probably
on.
starting to lose heart.
They can be
But
either
if you
real
keep on
or
just 2
imagined
more
patterns,
primes,
visual or mental,
2, 3,
static or
5,
dynamic,
7,
qualitative or quantitative,
11,
utilitarian
13,
or recreational.
multiply them together and add 1,
They can arise from the world
you
around
end up with
us,
30,000
from the pursuit of
and
science,
31,
or from the inner workings
which
of the
is
human
not
mind.
prime because it's a multiple of 59.
Different kinds
and
of patterns
509.
give rise to different branches of mathematics.
Okay.
For
So here we've got
example,
an example
arithmetic and number
of
theory
a number
study the patterns of counting
of this
and number.
form, which is not prime.
Geometry studies the pattern
And in
of
order
shape.
to show that not every number of that
Calculus
form is
allows us to
prime,
handle patterns of motion.
all you have to do is find a single
Logic
example
studies
of a number of that
patterns of
form which
reasoning.
isn't prime. And we've done
Probability
it.
theory deals with patterns of chance.
So that's the answer to question 8. That's how you
Topology
prove
studies
that
patterns
those
of
numbers
closeness
are not always
and
prime.
position.
Okay.
Fractal geometry studies the self-similarity found in the natural world, and so on and so on and so on.
Okay, let's see what we've got. Well,
One
number 1
major
has been done
consequence
for
of the
you.
increasing abstraction and complexity
two,
of the mathematics in the 19th
The simple
century
way to write that is to say 7
was that methods
less
developed
than or
to
equal
solve
to
important
P
real-world problems
less than 12.
had consequences that were counterintuitive.
The next
Let
one
me give you one example.
we would write
It's
as
called the
5
Banach-Tarski paradox.
less than x
It
less
says
than
you
7.
can, in theory, take a sphere and cut it up
next
in
one,
such a way
well,
that you can reassemble it
if
to form
x
two identical
is, let me see, if
spheres,
x is less than
each the
4,
same size as the original one.
then it's automatically less than
And
6.
that wasn't the only surprise.
So the second conjunct here
Mathematicians
is
had to learn to
superfluous. We
trust
could
the
just write that
mathematics above our
as x
intuitions.
less than 4.
Just as physicists did with the discovery of relativity theory and quantum mechanics.
What about the next one?
Of course, if you're
Well,
going to
y
trust
squared less
mathematics
than
above
9
intuition and common
means,
sense, you'd better be sure the math is
negative
right.
3
This is
is
why
less
the
than y
mathematicians in the 19th and early
is less than
20th
3.
centuries
That's what the
developed the
first,
precise way of
that's what the
thinking
second conjunct
I'm calling
means.
mathematical thinking.
Okay.
What this course is about.
But if y
Now for that
satisfies
quiz
this
I promised
condition,
you during my course introduction.
then certainly y is less than 4.
Did you read that short document called background reading?
So the first conjunct
If not,
is
I
superfluous,
suggest you pause the
and the only
video
one that
right
counts
now
is the second one.
and then come back after you've looked at it.
So we could simply write that as y squared less than 9. Okay, that was just our thinking.
Well,
on
the correct
way.
answer is money for the first question.
What about this one? Well, x is
People
greater than or
certainly
equal to
measure
0, and it's less than or
they
equal to
use various
0.
kinds
There's
of
only one
yardstick, but they didn't
possibility,
use numbers.
and that's
And they
x equals
certainly
0.
counted seasons, but you can count without numbers. You can count with notches
Well, for
in
number
sticks,
3,
and you can count
in
with,
order to show that
with
the
pebbles and
conjunction
so
is
forth.
true,
Our ancestors
what
only
you would do
invented abstract numbers
is show that all
in order to get money. At least that's the
and
best
phi
available
1,
evidence that we have, and that
phi
we
2,
think happened about 10,000 years
etc.
ago.
up to phi n.
For the second question, topology studies patterns of
And
closeness.
for number 4,
If you thought it was
to show that a
geographical
conjunction
terrain,
is
you were
false,
confusing topology with topography.
is you show that
How did you do? Well, for this one, the main
One
focus
of
in the 19th
phi
century
1,
became
phi 2
concepts and relationships. That was a
phi
revolution
n
in mathematics that took place in
is
Germany.
false.
And for this
So
question,
you have to find
at least
one
according
of
to
these,
me
at least
and
one of
many
these,
my colleagues
which is
actually
false,
point out,
and then it follows that the conjunct is false.
the main
Okay, well, that's that
mathematical
one.
ability today is being able to adapt old methods or develop new ones. Yes, use of technology is important. Yes, you need mastery
Okay,
of
well, with
basic
part
skills.
A, if
But the
pi is
crucial
bigger than
ability
10,
in today's world
then it's
is adapting
automatically bigger
old
than 3.
methods or developing new ones.
So in terms of the disjunct, pi
Okay.
bigger than 3
How did you do on that
dominates.
quiz?
That says more.
Yep,
If we
I
draw
know
a
it
picture,
wasn't a math quiz.
we've got 0,
It was
we've
really
got
there
3,
just to get you used to the
we've got
in-lecture quiz
10.
format. I gave the rationale for those quizzes
and the
on that
first
very
one
first
says
quiz.
that x is to
As
the
I
right
wrote
of this
there,
point,
The intention
and the
is that you
second
should find
disjunct
the
says
answers
that
to the
x is to
quizzes
the right of
immediately
that
obvious.
point,
If
and
you
the
do,
disjunction will be
that's a
true
sign that
if
you
at
are
least one of them
sufficiently
is true,
engaged and not trying to move
and at
too
least one of
fast.
them will be true if
If
we
you
start
find
at
you
3.
have to spend time on a quiz question,
First of
or
all,
go back and
only
look
the
at the
first
lecture
disjunct
again,
is correct,
then you will
and then
know
when we
that
get
you are
beyond
not
this point,
engaging sufficiently
both
closely,
disjuncts are correct.
and you need to slow
So
down.
it's the first one that works.
The secret to this entire
This
course
is that
reflection,
either x is less than
not
0
completion.
or x is greater than 0.
Doing all
So
the
the simplest
in-lecture
way to write
quizzes
that
is required to get a
is to
certificate
say
of
that x is
completion
not
for the
equal to
course,
0.
but does not
It's either
contribute
less
to your
than
final
0,
grade.
it's negative, or it's bigger than 0,
As
it's
those of
positive.
us giving and taking these first generation
This says
MOOCs
that
have
x equals
discovered,
0 or x is
in-lecture
greater than
quizzes
0.
are
The
valuable.
standard abbreviation for that
without
is
the
x
regular
greater than or equal
feedback
to
from an
0.
instructor or a TA, neither of
And
which
once
is
you've got
possible
x
with a
greater or
course
equal to
having many
0,
thousands of students.
That's going to dominate
The
over the first
individual
disjunct
student
in
has to
terms
monitor
of
his
the
or her
disjunction.
own progress.
So you're going to have x
The
greater than or equal
quizzes,
to
though
0.
simple,
That makes a
have
more
proved to be
general
very
claim
useful
of
in
the
that
2.
regard.
And for this
Oh,
one,
by the way, I know that some of you
let me
don't
make a
have
note that
constant
x squared
broadband
greater
access,
than 9,
and you have
this
to download
part,
the videos and watch them
means that
locally,
either
so you can't do all the
x
quizzes.
is greater than 3,
Well, they're all reproduced on the
or
course website with minor changes,
x
so you can
is
do them
less than
there
negative
when you
3.
go online. They're grouped by lecture. You should definitely
Well,
try
one
to
of these
do the
two
quizzes as
disjuncts
close in time
is
to
the one
watching
that's
the
here.
lecture.
So
As
this
that
one
will
is
help you decide
superfluous.
if you are moving at
So
a good
that's the one
pace,
that counts. So
which
x
for this
squared
course means
greater than
not
9
too
is a simple
fast.
way of saying it. And again, as
We
with the
professional
previous case, as
mathematicians
with numbers 1
despair
and
at
2,
school systems
as I was
that
going
impose
through them,
tight
I
time
actually
limits on
articulated
completing
what these things
mathematics
are.
tests and encourage fast work.
And these were really just to sort
Real
of prompt
math
you to
takes
thinking
time.
about how you would express them in English. Okay, well that's that
Before
one.
I dive into the first topic, let me say a couple of things about what to expect as we get into the course.
Well, in number 7, to
The
show
main
that the
thing to
disjunction is
realise
true,
is that a lot of what we do
you have to
probably
show that
won't seem like doing math,
one of them
since the
is true.
focus is on how to
At
think
least one of them.
mathematically, not how to apply standard techniques to solve problems. For most of you, if you've had a fairly standard
And for
high
number
school
8,
mathematics education, this
To
is
show
a
that
big
it's
shift.
false,
Second, even when we
you have to show
do
that
math that looks familiar to you,
all
you'll spend
phi
most
1,
of the time
phi
thinking
2,
rather than writing things down.
to phi n
If at all possible,
are false.
you should work with somebody else or in a small group. Learning to think a different way is a lot harder
That's number
than
7 and
learning
8
a new
taken care of.
technique, and few of us can do it alone.
Well,
If you
turning to
find you
number
need
9
help,
now,
or if
to
you
say
think
that it's
there's a
not the
mistake
case
in
that
something
pi
I've
is
said
greater
or
than
written,
3.2,
the first thing to do
is to say
is
that
discuss
pi
it with your study group or in the course
is
discussion
less than or
forum.
equal to 3.2.
If, after discussion,
When you
your
negate a
group
strict
thinks
greater
there's a
than,
mistake,
you get less than or
post
equal
it on
to.
the forum to see what others think.
To say that it's not the case
That
that x
way,
is negative
issues that arouse a
is
lot
to
of
say that
interest
x is greater
will
than or equal
rapidly
to
rise
0.
to the attention of me and my teaching assistants.
To say that
Okay.
it's not the, well,
Now we've
these
got
are
you
real
orientated,
numbers
disposed of the
from the
preliminaries.
context
Let's get down to work in
of
earnest.
the expression.
The first topic
We can
is
assume
getting
that these are
precise
talking
about how
about real
we
numbers.
use language.
And for a real number, every real number has a square which is strictly positive with one exception.
The American
exception
Melanoma Foundation,
is
in its
0.
2009
So the only
fact
real
sheet
number
states
for
that
which it's not the case that x
one
squared is
American
strictly
dies of
positive
melanoma
is x equals
almost
0.
every hour.
The standard abbreviation
Like
for
many
not x
mathematicians,
equals 1
I can't
is
help
x
being amused by
not
such
equal to
claims.
1.
Not because we mathematicians
And
lack
when you
sympathy
negate
for
a
the tragic
negation,
loss of life.
it takes you back to the
What we find
original
amusing is that
statement.
if you take the sentence literally, it does not
And again,
at all
as I
mean
went
what
through
the
them, I
AMF
essentially
intended.
answered number 10.
What that sentence actually claims is that there is one American, let's call this person X,
Well, this
who has
question is
the
much more difficult
misfortune
than all of the other
to
ones.
say nothing of
And
the
the reason is
remarkable
that,
ability of almost instant
you take
resurrection
Statements
to die of
in natural
melanoma
language,
every hour.
and they have all sorts of
The sentence
ambiguities,
that
they
the
have
AMF writer
nuances, they
should have
depend upon
written
context
is
for
this.
their interpretation, they
Almost
depend
every
upon
hour,
knowledge of the
an
world.
American dies of melanoma.
And when you try to distill out
You see the difference?
precise mathematical meanings,
Misuses of
there's so
language
much
like
lost
this are
that
fairly
in
common.
many cases
So much so
it's not
that they
exactly
really
clear
aren't
which the
misuses.
right answer is.
Everybody reads the
I don't think that's the case with the first
as
one.
having
I think
the
that's
meaning
fairly
captured
straightforward.
accurately by the second.
That's just D and Y.
Such sentences have become figures of speech.
I think the
Apart
second
from
one is fairly
mathematicians and
straightforward
others
too.
whose profession requires
Okay.
precision of
The
language,
dollar is weak,
hardly anyone ever
and as a
notices that
result,
the first sentence, when
the
read
trade
literally,
agreement fails.
actually makes an absurd claim.
Okay, there's a definite implication in this
When
one, I
people
think.
use language in everyday
This
context
one,
to talk about
I think
everyday
this is much less clear.
circumstances, they share a
I would
common
be
knowledge
inclined
of
to
the world,
say
and that common knowledge can be
that
relied
it's-
upon to
the dollar
determine
is
the
weak,
intended meaning.
and the yen is
But when
strong,
mathematicians use language
and there's a
in their
trade
work,
agreement.
there often is no shared common understanding.
In other words, I'm not interpreting
Moreover,
this as saying
in
that the
mathematics,
trade
the need for
agreement
precision
implied that.
is paramount.
I'm simply saying that there was a
That
trade
means that
agreement,
when mathematicians use
and then after
language
the
in
trade
doing
agreement,
mathematics,
it turned
they
out
rely
that the
upon
dollar was
literal
weak and the yen is strong.
they have to.
Now
As a
you
result,
may
Mathematicians have
say,
to be
no,
aware
no,
of
this
the literal
should be
meaning of the
interpreted
language
as
they
that
use.
this implies that. In which
This is
case
why
the
beginning
alternative
students
would
of
be
mathematics in
there's a
college
trade
are
agreement, and as a
generally given a crash
result,
course in the precise
the
use
dollar
of
is
language.
weak and the yen is strong.
Yeah, that might sound like a
So
huge
that would be
undertaking,
an alternative.
given the enormous breadth of language.
Incidentally, later on, when
But the
we
use
look
of
at the
language in
way
mathematics is so
conjunction and
constrained
disjunction,
that
negation
the
and
task actually
implication
turns out to be
behave,
relatively small.
we'll be in a position to examine and
Modern pure
analyse
mathematics is
the
primarily
connection between a
concerned with
statement like
precise
this and a
statements
statement
about
like that.
mathematical objects.
Are they equivalent? Are they different? In what
Mathematical
way are they
objects are
different?
things like integers,
Okay, let's
real
move
numbers,
ahead.
sets,
Strong
functions,
dollar
etc.
means a weak
Here are some
yen.
mathematical statements.
I think there's a definite implication there.
There are infinitely many prime numbers.
Strong dollar
For every real number
means the
a,
yen is weak.
the equation x squared plus a equals 0 has a real root.
Despite,
The square root of
I think
2
that
is
to me that's
irrational.
just a nuance on
If
conjunction.
Pn
actually.
denotes the number of primes less than or
I
equal
would
to
be
the
inclined to
natural
say
number
that's
n,
that.
then as n becomes
The
very
yen
large,
is weak
P of n
There's a
approaches
trade
n
agreement,
divided log e of
and the
n.
dollar is strong.
Not only are mathematicians
Just a
interested in
straightforward
statements like
conjunction of the
these,
three.
they are
And
above
that
all
despite
interested in
adds
knowing which
an extra
statements are true
sort of
and
emphasis
which are false.
that it's
The truth
it's
or
counter
falsity
to what
in
one
each
might
case
normally
is
expect.
demonstrated not by
Okay, this one I
observation or
think is
measurement or
fairly
experiment,
straightforward.
as in the natural
If
sciences,
one of them is the case,
but by a proof.
the other one cannot be the case.
In this course, we look at some
I've said that
different
if
ways
the
of
dollar's
proving
strong,
statements.
the yen has to be weak.
In the case of
um,
my 4 examples,
The alternative
1,
that you
3
might want
and
to
4
say
are true,
is if the
but
yen
2
is strong,
is false.
then the dollar is weak. Again, when we
Let
look
me
at
show
the
you a proof of the
calculus
first
that
statement.
tells us how
It's due to the ancient Greek
negation,
mathematician
implication, and
Euclid,
so forth
who lived around
interact and affect
350
each other,
BCE.
we'll be able to investigate whether or not that and that are actually equivalent.
We show that if we list the
So
primes,
bear this example
P1,
in mind
P2,
when we
P3,
come to the
etc.,
couple of
the
lectures.
list continues forever.
G, if new trade agreement is
suppose we've reached
signed,
some stage
dollar and
N.
yen can't
So
go
we've
to remain
listed
strong.
P1,
I think that one's
P2,
fairly
P3
straightforward.
up
If
to
the
Pn.
trade agreement
Can we
signed,
find another prime to
then
continue the
you
list?
can't have them both
If we can
strong.
always find another prime,
Someone's going
then
to
the
win and
list goes on
someone's going to
forever,
lose.
and we've shown that there are infinitely many primes. Well, can we?
This one,
Well, here's a clever
think-
trick.
well, to me, that I
Euclid
can only
described
really
in
see
his
one
famous book
interpretation of
Elements
this.
in 350
It's conjunction.
BC. Look at the number n
T
defined
not
as
D,
follows.
and not
Set
Y.
n equal to
You can have,
P1
you can have the
times
trade agreement,
P2 times P3,
and you can have the dollar
all the way up to Pn,
falling,
multiply them all together,
and the yen falling.
and add 1.
Not being strong. Not being
Clearly, n is bigger than Pn.
strong.
So if n happens to be prime,
Again,
we found
but
a
I
prime
think
number
it's
bigger
just
than Pn,
a
and we can continue the
a
list.
nuanced way of talking
If
about
n is not
conjunction.
prime,
So I would say
then
that
it's
that
going
was
to be
not
divisible
T
by a prime, say
and
P.
D and
Now
Y.
P
The trade
cannot
agreement
be
fails.
any of the primes
and the dollar is
P1,
strong,
P2,
and
P3
the
up
yen
to
is
Pn.
strong.
Because if
And
you
its last
divide
one,
any of those primes
I
into
would say is a
n,
definite implication.
that
you've got a
prime
trade
will divide
agreement.
into this part, and then there's a remainder of 1.
As a result, one of
P
them
cannot be any of
is
those.
strong.
Why?
They're not both strong.
Because dividing them leaves a remainder of 1. So P is bigger than Pn. That means we've
Okay.
found a prime number bigger than Pn.
Because of the
Either
trade
way,
agreement,
If n is
either
prime,
the dollar is strong
or if it's
or the
not
yen is
prime,
strong.
we've shown that there's a bigger prime,
But disjunction, of
than
course,
Pn.
can include both.
which means the list
Whereas
can
this
always be
says
continued.
only one of them.
And that proves that there
So
are
we have
infinitely
to
many
exclude
primes.
the possibility.
Let's just take another
they're
look at
both
what we've
true.
done. We start with a
Well,
list of
okay.
all of the primes.
These are my
Try to
answers. You
solve
may
the
disagree on one or two
We
of
have to
these.
show that we can do that and keep going. Okay, so we start
And
with
like
a list
most
of
of
the
the
primes. We
course,
assume we've reached
the
some
focus
stage
is
n.
actually
N
not
could
on the
be
answer,
10,
it's on the
million,
thinking
billion,
process.
trillion,
The
whatever.
benefit from doing an
We've
exercise
reached
like
some
this
stage,
is not really whether
and we
you get
show
the
that
same
we
answer
can
as
always
me.
find
It's
another
the thought
prime
process you went through
bigger than the last
in
one.
order to take something in English
do we do
language
that?
and formulate
Well, there's
it
a
in
clever
mathematics.
idea.
This is actually
We
a
look at
very
this
special
number
case of
big
what's
N,
known as
which means
mathematical
you
modelling,
multiply the
taking a
first
problem
little
or
n
statement in
prime,
the real
just a little
world
in there, you multiply
and
them
representing
together,
it
you
within
add 1.
mathematics. Mathematics is
N is certainly
precise.
bigger than the last one in
The real
that
world is
sequence.
usually not so precise.
So if big N is
There's a
prime,
loss when you go from the
then
real
it's a
world to
prime bigger than
mathematics.
Pn.
But there's also,
Now, we're
again, you
not
gain
saying that
precision
big N
at
would
the
be
cost
the
of
next
losing
prime after
some
Pn.
some
In fact, it
imprecision.
almost certainly wouldn't
And
be, because big N is a lot
and when you
bigger
do that,
than these numbers.
there are often choices
so this
to be
number
made.
is a lot bigger.
Okay, well,
than
how did you
Pn.
do on
so
the whole
this is going
assignment?
to be the next prime, almost certainly. But that doesn't matter. We've shown that there is another prime, and whatever the next prime is,
Well, judging from the
we'll put
discussions
it
on
on
the course
the
forum,
alternative was that N wasn't prime.
in problem set
in which
1,
case
the questions that
it's divisible
caused
by a
people the
prime,
most
and we call it
difficulty
P.
were numbers 6 and
Now,
7.
that
Those are those
prime
questions
P
about Alice.
Can't be any of these. Why?
And
well,
let's
this
just
is
see,
why we defined
let's see
N
what's
the
going
way
on
we
here.
did.
Notice that in each
If you
of these,
divide N
we've
by
got the
any
same
of
phrase,
these
works in a
primes,
bank,
you're left with a remainder of
works in a
1.
bank, works in a bank,
So the prime that
works in a
divides
bank,
N can't
works
be
in
any
a
of
bank.
these. It must be a different one.
but for
If it's a
4 of
different one,
these,
it's bigger
there's an
than
additional
Pn.
requirement.
So again, we found
Not
a
only does she
prime
work
that's
in a
bigger than
bank, but
Pn.
something else, works in a bank, something else,
Is
works
this
in a bank,
prime P the
something
next
else,
prime after Pn?
works
Well,
in a
it
bank,
might
something
be,
else.
but there's no reason to
Each
assume
of
it is, and it
these
doesn't matter.
additional
The
requirements,
point
each
is
time
we
you've
found
got
a
one,
prime bigger than Pn.
it makes it less
so
likely
once
to
again,
happen.
the list can be continued.
Because you've got something else to satisfy.
Either
They all
way,
have to
the list can be
satisfy the fact that
continued.
Alice works in a bank, but for the first 4, Alice also has to satisfy something
This
else.
is the clever
So
trick
each of
that makes it
these
work.
makes it less likely.
Defining N that
It makes
way,
it less
so we
likely to be
define
true.
N that way
So this one,
to make
is the one
sure that
most
if there's a
likely to be
prime
true.
dividing big N, it won't be equal to any of those.
now it's possible that in a particular instance, another one
Theory
has the same
true.
likelihood.
There are infinitely many
We're not
primes.
saying that there's a unique most likely
How
one,
about that?
but we are saying there's a
So
most
we've
likely.
proved the first of our 4 examples.
Incidentally, it doesn't
There are
matter whether you
infinitely many
express in
prime
terms of the
numbers.
word likely or
That
the
one's
word
true.
probable or
What
probability.
about the second
You
one?
can do it numerically. You can do it
Well,
however
it
you
says
want.
that for every
The
real
issue is
number
not
A,
what the word is.
the
The issue
equation
is
x
the
squared plus a
information you
equals
have.
0 has a real root.
And in each of these
That
cases,
turns out to be
you
false.
have an extra restriction. And whenever you've got an extra
To show that it's
restriction
false,
with a conjunction,
all you need to do is
it's
find a
critical
single
that
real
it's
number
conjunction
A
when you've got
for
an
which the
extra restriction
equation
with a
does not
conjunction,
have a real
it
root.
makes it less likely. Because
Well,
instead of just having to
why don't we
satisfy
just
one
take
thing, you have to satisfy
A
2 things.
equals 1.
And when you satisfy 2 things things, it makes it less
then we
likely to
know
happen. So regardless of whether you use the word likely, probable, whatever you want to do,
plus 1 equals 0.
The most likely one
does not
is this
have a
one,
root,
because this is the easiest one to satisfy.
You can square, no real number that you can square.
And this actually, I think, is a great example.
You get
of
0.
mathematical thinking.
The square of any real number is positive.
I mean, this is a
Take a positive
superb
number
example
and add 1, you
of
end
the
up
kind
with
of
a
thing I'm
positive
talking
number.
about in this course. Because we're
there is
arguing
a real
purely in
number
terms
A
of
for which the
mathematics. In
equation does
fact,
not have a root.
it's the mathematics of the word and. The
That
reason this is
shows
in this problem set
that the
is
statement
because this
that
is
for
all
every
about the
real
way
number
and
there's a
works.
root
So if you really
is
understand
false.
how and works, this one just drops right
What
out.
number 3?
That's why it's
Well,
there.
it turns out
It's
to be
to
true,
to make you
and
really
we're going to
reflect
prove that's true
on
later
conjunction
in the
and the
course.
power of conjunction. Okay,
The
so
fourth
it's,
one, this rather complicated looking statement
there you
about
go.
the distribution of the prime
It's all to
numbers.
do with the amount of information
That's
you
a
get.
very
Incidentally,
famous
all
results
that
that was
probability
proved
theory
at the,
does, I say all, I mean
about
probability
just over
theory is a
100
powerful
years
theory.
ago,
But what
at the end of
probability
the
theory
19th
does
century.
is adds
It's known as
numbers
the prime number theory.
to the amount of information
So this
you
one
have.
is
Okay,
true.
and in this case, the
Prime
extra
number
information
And
is
there
more
we are.
restrictive. And when you assign
Well, the correct answer
probabilities to that,
is false.
that gets reflected.
The proof certainly
Okay,
involved
well, that was
looking at
number
this
6.
number,
Let's take a look at number
but
7.
it didn't require that this number be prime. It was rather different.
Well, number 7
So
is
if you've
slightly
got
different.
if you thought the answer
Because
was
we
true
don't
here,
have a common
I would strongly
expression
advise you to go back
in all of
and
the
look at
all
that
of the
proof
5.
again,
In the
because
case
we
of
most
works in a
definitely
bank.
did not assume that this number
In
was
this
prime.
one, we have works in a bank and something else. This one we've got is a rock star.
Clearly,
This
before
one
we
we've got
can
works in a
prove
bank
whether a
and
certain
something
statement
else.
is true or
This one we've
false,
got works in a bank.
we must be able to
we've got
understand
works in a
precisely
bank.
what the statement says.
Okay.
Above all, mathematics
The other
is a
thing
very
here is being
precise subject
quiet, being
where
honest,
exactness
and
of
so
expression
forth.
is required.
But if you look through these,
This
this one
already
has
creates a
works in a
difficulty,
bank
since
and
words tend to
something
be
else.
ambiguous. And
So
in
this
real
is less
life,
likely
our use of language is
than
very
working
precise.
in a bank.
In
This
particular,
has been a rock star,
when we use
this is
language
honest,
in an
and so this
everyday
one is
setting,
also less
we
likely than
often
working in
rely
a
on
bank.
context
So if we're looking for the
to
most
determine
likely
what our
thing,
words convey.
these make them less likely.
For example,
So let's just
an
sort of
American
ignore that
can
part.
truthfully say
That makes it less likely.
July is a summer
It's already
month.
more likely that she works in a bank.
But that would be false
This one there's
if
nothing to
spoken
ignore.
by an
This
Australian.
one she works in a bank.
The
So
word
we've got either
summer
working
means
in a
the same
bank.
in both statements.
You know,
Namely,
this is more
the
likely
hottest
than
3
it was
months of the
originally.
year.
So I'm making things more likely.
But it refers to one part
Here
of
we've
the
got
year
Alice
in
being a rock
America
star.
and another in
And
Australia.
this one,
In everyday
either
life,
she's a rock
we use
star
context
or she
and our
works in a
general
bank.
knowledge of
So
the
this
world
is the most
and of
general
our
one.
lives
This is
to
more
fill in
likely.
missing information in what is written or said.
Because there are two
and to eliminate
chances
the
here,
false
either working
interpretations
in a bank
that can
or being a
result
rock
from
star.
ambiguities.
Here there's just one of them, here's just
For
one
example,
of them, here's one of them, and here's
We
just
would
one of
need to
them.
know something about
Okay,
the context
so the most likely
in order
one
to correctly understand the
is
statement,
this one.
the man saw the
because of
woman with a
disjunction.
telescope.
There
Who
are
had
two
the
ways
telescope?
that
The
she
man
could satisfy
or the
this,
woman?
by being a rock star and working in a bank. In each
Ambiguities
of
in
these,
newspaper
there's
headlines,
one of them.
which are generally
And I've
written in
ignored
great
the thing that
haste,
makes it even less
and
likely.
sometimes resulting
So
unintended
having modified that,
but
I've made
amusing
B more
second
likely.
readings.
Having
Among
modified
my
D, I've made it
favourites
more
that have
likely.
appeared over the years are
So now I've just got works in a
Sisters
bank, works in a
reunited
bank,
after
rock
10
star,
years
works
in
in a bank.
checkout line at Safeway.
But there's only one of them in each of that.
Large
In this
hole
one,
appears in
there
High
are two
Street.
of them.
City
So again,
authorities are looking into it.
purely by using
Mayor
mathematical
says
thinking,
bus passengers should be belted.
I've arrived
Okay.
at the one that's most likely. And as in number 6, it doesn't matter whether you take express
so
it in
people
terms
can
of
communicate
probabilities or
effectively by
relative
defining
probabilities,
exactly what each
however you
word
want.
is to
Incidentally,
mean
probabilities, there are
would
many
be an
different types of
impossible task.
probability. There's frequentist
also be
probability,
unnecessary,
there's Bayesian probability,
since people
there's
generally
subjective
do just
probability,
fine
there's
by
epistemic
relying on
probability.
context and background knowledge.
Assigning numbers to the information you
mathematics
have
things are
and
different.
calling them probabilities
Precision is crucial,
is a pretty
and
tricky
it
thing. There
cannot
are
be
many
assumed
different
that
ways
all
of doing
parties
it.
have the same contextual and
and
background knowledge in order to
it's
remove
just a very
ambiguities.
complicated issue. So those
Moreover,
of you who actually
since
try to use
mathematical
probability
results are
theory, that's
regularly
fine, you
used
can
in
do it.
science and
But it
engineering,
actually gets more complicated.
the cost of
Not least because
miscommunication
you
through
end
an
up having to talk
ambiguity
about whether things
can be
are
high,
independent
possibly
events
fatal.
and so forth. And the point is,
At first, it
you
might
don't
seem
need
like
any
a
of that.
Herculean task to make the use
remember
of
at the
language in
beginning I said
mathematics
this
sufficiently
course is not
precise.
about rushing in and applying
unfortunately,
techniques
it
or
turns out to be
procedures.
very
It's
doable,
about
though a bit
thinking
tricky in
basically
places.
about the issues.
And
And
what
you don't
makes
need
it
the machinery
possible
here.
is the
If you
special,
think about the
highly
issues,
restricted nature
it
of
comes
mathematical
out.
statements.
Remember my exhortations? Look at a problem,
Almost
ask
every
yourself
key
what it
statement
means,
of
what is it
mathematics,
saying,
the axioms,
and try to
conjectures,
reason in terms
hypotheses
of the
and
problem
theorems,
itself. Don't
is a
look for
positive or
techniques
negative
to apply.
of
You
one
often
of
need to do
four
that, but in
linguistic
this case,
forms.
that's not what the course is
Object A
about.
has property
And
P.
many of the questions I'm giving in this course should be solved not by applying a
type
technique,
T has property P.
but by just thinking about the problem.
There is an object of type
let me
T
finish
having
this,
property P.
this tutorial on the problem session, and these are the only two
If
problems I want to
statement
look at.
A,
Let me
then
finish that,
statement B.
this tutorial session,
Or else the statement is
with a
simple
different problem
combination
of the same
substatements of
kind,
these
where you can
forms,
solve it just by thinking
using
about
the
the problem,
connecting words,
not applying
which
a
we call
technique.
combinators, and, or, and not.
And here is that problem. Okay?
For example,
You've arrived late at an airport,
3
you're
is a
rushing to
prime
catch your
number.
plane.
Or 10 is not
Unfortunately, your gate is at the far end of the terminal.
a prime number. Every
It
polynomial
always seems to
equation
be at
has
the
a
far end of the
complex
terminal,
root.
doesn't it? The fastest you can walk
It's
is a
not the
constant
case
speed
that
of
every
4 miles per
polynomial
hour.
equation has a real root.
For part of the way, there's a moving walkway moving at 2 miles
There is a
per hour.
prime number between 20
You
and
decide
25.
to take the walkway and continue to
There's
walk.
no even
So you're going to
number
walk
beyond
all
2
the
that
way,
is
but
prime.
part of the, when there's a walkway, you're going to walk on the walkway. Yes, so you
if
can go
P
faster.
is a prime
right?
of the form 4n plus 1,
Just as you're about to step onto
then
the
P
walkway,
is a sum of 2
you
squares.
notice your shoelace is loose. And the last thing you want to do is get your shoelace caught in the,
In their
in the
everyday
mechanism
work,
of the walkway.
Mathematicians
So
often
you've got a
use more
choice.
fluent
You
variants
either
of such
stop and
statements,
fasten your shoelace
such
just
as
before you step on the
not every
walkway,
polynomial equation
or you
has a real
step on the
root.
walkway
Or
and then stop
no
to fasten
even
your
number is
shoelace
prime
whilst the
except for
walkway
2.
is moving you along. And there's
But
no
those
other
are just
options. Those are the two options you have.
variants.
Which option will get
Incidentally,
you to the gate
the
fastest?
final statement about the primes of the
Now,
form
there are two
4n
ways you
plus
could try
1
to go about this.
is a
You could try to
celebrated
argue in
theorem
terms
of
of
the early
speed and
19th
adding the speeds
century
together and so
mathematician
forth.
Carl Friedrich Gauss.
And if you do that, you're going to run into a problem. There's going to be some information that you need
The
that you don't
ancient
have.
Greek mathematicians
For
seem
example,
to
I
have been
haven't
the
told you
first
how
to
long the
notice
walkway is and
that
how long
all
you had to walk
mathematical
in general.
statements can be expressed using one
So
of these simple forms.
There's a problem if you try to use
And they
standard
made a
methods.
systematic study of the key language
However,
terms
you do have
involved,
enough information
namely,
to solve the problem.
and, or, not, implies,
But if you
for
try to
all,
apply
and there exists.
relative speed, the kind of methods you were taught to use in
The
the
Greek
high school for
mathematicians
solving
provided
problems
universally
about
accepted
speed,
meanings
relative
of these
speed
key
and so forth,
terms and analysed their behaviour.
you're going to run into problems. And you don't need that.
When that
if you
study
think
is
about the
carried out
problem,
in a mathematically
You
formal
should be
way,
able to solve it.
it's known as
Well, I'm
formal
just going to
logic
leave you with that one.
or mathematical logic.
It's an interesting problem. I think it's a rather
The
neat
study of
problem. There are
mathematical
many
logic
problems
is
like
a
this
well-established
that you
branch
really
of
can just solve
mathematics,
by mathematical thinking.
studied and used to this
And the
day
point is,
in
this
university
again
departments of mathematics,
all
computer
about
science, philosophy and
this
linguistics.
important
It gets a lot
notion
more complicated than the original
mathematical
work
thinking.
carried out in ancient Greece by Aristotle and his
It's
followers
powerful.
and by the Stoic
If you can
logicians.
master mathematical thinking,
But that's well outside
many
our present
problems can be
interest.
resolved without
It's time
going
for
into
another
the
quiz.
complexity of applying mathematical
Let me stress
techniques.
what I wrote to accompany the
Mathematical
first in
techniques
lecture
are what
quiz.
you need
The
when
quizzes
mathematical
are
thinking
designed
alone
so
doesn't
that
work.
if you're progressing in a manner that will
But
get
often
you through
can
the
get by
entire
with just
course,
mathematical thinking.
you'll find the quiz is
So,
easy.
good luck on that one, and
In most
enjoy
cases,
it. It's
the
a lot
answer
of
will
fun.
be obvious. Their role is so that if you find you're getting some quiz questions wrong,
How did you get on with
or if you have to
assignment
check
five?
back through the lecture before you answer,
Mastery of quantifiers is
then
the
you'll
one
know
last
you need to
ability
put in
you
more
need
focus on
to be able
mastering
to
the
cope
material.
with definitions of mathematical concepts.
You have
and
to
with
do all the
mathematical
quizzes
reasoning.
to get the course completion certificate,
I'm
but your
going to
course
begin
grade
by looking at the
comes
way
from the
negation
weekly
affects
problem sets
quantifiers.
and the final
But
exam.
before I start, let's see
So
how
here's
you're
the quiz.
progressing by way of a quiz.
Okay,
The
let's see what
ancient
we
Greeks were the ones who began the
have. Is it
formal
the
study
case
of
that
language
for
and
every real
reasoning
number x,
that became
x
the
plus
branch of
1 is greater
mathematics
than or
known as
equal to
formal
x?
logic?
Yes, it is.
And that brings us to the end of the first lecture. Your
Is it
next
true
task
there is a real number x?
is to complete course
such that x
assignment
squared
1.
plus 1 equals 3.
You'll probably
that would
find it
mean
easy
x
to
squared
print off the
equals 2.
PDF file and work on it
So
when
we're
you
really
have time.
saying, is it true that there exists a number x?
It's really hard to say how
whose
much
square
time
is
you should
2?
allow for the course assignments.
Well, if we were talking
As
about the
people
rational
work at
numbers,
very
the answer
different
would be no,
rates.
because the square root of 2
The
is
first
irrational.
one is meant to be
But
pretty
for the
light.
real numbers, it's
So
true.
I'm guessing that an hour or so should be enough
What
for
about
most
this
of
one?
you. But I really can't be sure.
Well, for very large
if you're
negative
ever
x,
uncertain about anything in a lecture, a reading,
x
or an
cubed is an
assignment,
extremely large negative number
discuss
which
it
will
with your study
dominate all
team
of these numbers.
or go on to the course
So for
discussion
large
forum.
negative x,
In fact,
this expression,
even
this
if you
cubic
don't
expression,
feel
is
uncertain,
negative.
you should
So it's
discuss
not
the
the
course
case
material
that it's
regularly
always
with other
positive.
students.
So that one's false.
Many students do
What about
fine
this
at
one?
high school working on their own.
Is it true that for all x there is a y?
In fact, the best
x cubed
students
plus y
usually work
cubed
that way all
equals
the
0.
time.
That would
I
mean
did
y
when I was at
cubed
high school.
is equal to minus x
But when I
cubed.
got to university, I soon discovered
answer
that
is
working
yes.
alone was the worst possible strategy.
Given any x,
University
just let y be
mathematics is
negative
not
x.
focused on learning procedures to solve
when you
problems.
cube a number,
It's about thinking
you
a
cube a
certain
positive
way.
number, it's
And
positive.
mastering a new
You
way
cube
of
a
thinking
negative
is
number,
best
it's
learned by
negative.
working in groups.
So
by taking
In a
y
MOOC,
equals negative
where
x
you
in
don't
all
have an
cases,
instructor or a
you get
TA
0.
to
So this
regularly
one's
check
true.
on your progress, working
about
with
this
a
one?
study group is pretty well essential.
Is there an x
The folks at Coursera are working on developing their platform to facilitate group work.
If the quantifiers
but
were
that's
the other
not
way
available
round,
to us now.
the answer would be yes.
So you'll have to form and manage
For
your
every
study groups
y,
yourself.
there is an x. Such
Of
that
course,
x plus y equals 0.
the course discussion
Then let
forum
x be
provides a
negative
starting
y.
point.
But, it's
But
not
you
the
should
case there
use
is
whatever
one x that
medium you
works for all
prefer
y. So that one's
to
false.
keep in touch with other students.
What about this one?
Forming a group on
Well, is it the
Facebook,
case
Google
that for
Groups,
all
Yahoo,
x,
etc.
there is a y,
are all obvious ways to do it.
such that if x
And you
is
can share
non-negative,
files and work together
then y
on
squared
Google
equals
Docs.
x. Well,
Check out the
not.
course website for
Suppose we took an
information,
x.
recommendations, suggestions,
if
and
x was
updates.
negative, then
And keep in
game
touch
over,
with the rest of the
because
class
this conditional would
by
be true.
following
It would have a
activities on the
false
forums.
antecedent.
Good luck, and I'll see you
If
next
that
time.
x was non-negative, then there is a y
Welcome
whose
to the
square is
second
x,
lecture.
namely the square root of x.
I hope you're making progress with the first assignment.
So whatever x we take,
I'll post my
there's
answers to
always
some of
going
the
to be a
assignment
y
questions
that
later.
satisfies this.
Consult the course schedule
It's
on the
true.
website and check regularly for
You might
announcements
have
of
to
any
think about
changes.
this one a little bit.
You should
because
not
there are two
expect to
cases
solve all the
involved.
problems in an assignment in a single session,
Given an x,
or even before the
you
next
can find
lecture.
a y
What you should do before the next lecture
that makes
is
this
attempt
thing
each
true.
question. That's what I mean when I say complete the assignment.
If the x you're given
Remember,
is negative,
the goal of this course
any
is
y
to
will
acquire
make
a
that true.
certain way of thinking, not to solve problems by a given deadline.
because if the x is
The
negative,
only
the
way to
antecedent is
develop a
false.
new way of thinking
But if the
is
x
to keep
you're
trying
given
to think in different ways.
satisfies this condition, if the x you're given is non-negative,
Without guidance,
then the
that
y
would be
you
unlikely
pick
to get you
is the
anywhere,
square
of
root of
course.
x.
But the point of a course
See
like
what's
this
going on?
is to
If
provide
you're
that
given
guidance.
a negative x,
And the assignments
there's no
are
y
designed
that
to guide your
satisfies y
thinking
squared
attempts in
equals
productive
negative x,
directions.
not in the real numbers.
Okay, let's proceed.
But that eliminates that case.
As a first
So this
step in
one's quite
becoming
subtle.
more precise about our use
I
of
suggest you
language
think about this
in
one.
mathematical contexts, we'll
It's the
develop
kind of
precise,
thing that you encounter quite a lot in
unambiguous
math.
definitions of the key connecting words and, or, and not. The other terms we need to make precise: implies, equivalent, for all, and there exist, are more tricky, and we'll handle them later. Let's start with and.
We often want to combine two statements into a single statement using the word and. So we need to analyse the way the word and works. The standard abbreviation that mathematicians use for this is an inverted V, known as the wedge. Sometimes you'll see the old familiar ampersand used, but I'm going to stick to the common mathematical practice of using the wedge. For example, we might want to say pi is bigger than 3 and less than 3.2. We could do this as follows. We could write pi is bigger than 3 and pi is less than 3.2. In fact, for this example, where we're just talking about the position of numbers on the real line, there's an even simpler notation. We would typically write 3 less than pi less than 3.2. But as an example illustrating the use of the word and, this one is fine. What does it mean? Well, if we have two statements, phi and psi and psi means that they're both true. The official term for an expression like this is it's the conjunction of phi and psi. Relative to the conjunction, the two constituents phi and psi are called the conjuncts of phi and psi. What are the circumstances under which a conjunction phi and psi is true? Well, if phi and psi are individually true, then the conjunction phi and psi will be true. Under what circumstances will phi and psi be false? Well, if either phi is false, or psi is false, or they're both false. This might seem very self-evident and trivial, but already this definition leads to a rather surprising conclusion. And here it is. According to our definition, phi and psi means the same as psi and phi. They both mean that phi and psi are both true. In mathematical parlance, conjunction is commutative. But that's not the case for the use of the word and in everyday English. For example,
Don't stop.
Just to do her hair now, because she cares, y'all. Her day I wouldn't be right without her makeup. She's never had a makeup. She's just like you and me, but she's homeless. She's homeless. As she stands